How's it going, Will? I know this is coming in a little bit late, but I just wanted to show what I had with my plugin in case my paper doesn't really suffice. I thought I'd have it working by this morning, um, but it seems like the errors I'm getting are occurring with my delay. The way I'm reading and writing my delay buffers. Let me see in specific. Where is it? Yeah, I think it's the way I'm reading, and I know I'm supposed to be passing into the delay line, the Echoplex delay mod, like whatever value I get from that. I wasn't entirely sure how to do that, so whenever I run it, I get some error that that this phrasing right here isn't right. Like for example, even if I do it right now, yeah, non-standard syntax, and and those are my only errors, for throughout the file. But besides that, I have my Echoplex delay mod working. It seems like maybe I have one or two lines to change here. But I'm just gonna walk through and explain what I did for each, just so you know that I understand everything. And also, this is what I had. I didn't have enough time to create the GUI, but on top right here we have like all the Echoplex delay mod knobs. So we have, for every LFO and the triple LFO, we have the frequency cutoff, the starting phase, the amplitude. Then we have the depth control and for the LFOs as well as the noise depth, which is the LF drift. And then we also have the frequency cutoff of the noise, the amplitude of the noise, and then we have the comb filter delay time as well as the overall delay time, which I know we're taking this and we are mapping it to two different things. The inverse comb filter as well as the noise generator. So, starting with the Echoplex delay mod, here's my structure for it with all the knobs you saw in rack effects. So we have the frequency, phase, amplitude. Then here we have the depth percentage of the LFOs as well as the noise, the frequency cutoff of the noise, amplitude, comb delay, time in milliseconds, and delay time. So if we continue on, going to the bottom, just seeing our member variables, we have we have defined the triple LFO, a noise generator, and a universal comb filter. And then in order to get that kind of working, we go to reset. The triple LFO, we set all the knobs we're getting into it, and then the noise generator we're setting frequency cutoff and the output amplitude, and then we are making sure to select the comb filter type and that it's inverse comb filter for the scalloping filter. Hopefully I'm pronouncing that right. Then these are used for the poly mapping. So you could see, should be in the LF drift. Yeah, calculate drift of the normal. Well, first we need to normalize our delay value coming from the delay time, and then here's our range, 0 to 700 milliseconds, and then we throw it into the calculate drift depth, and that was from the graphs you gave us, where you had with the growing delay time, the depth would increase. So we went on like mycurvefit.com or something, and this ended up, for me, I chose a third order polynomial because I felt like it matched pretty closely to my curve. So here it is right here, and I'm returning it, and then that value is right, where is it? Oh, yeah, then I do bipolar modulation on that value, and then that modulated time gets passed through, or is multiplied by the filtered noise out from the noise generator. And a similar thing happens here for the triple LFO, except it's using a constant instead, and that constant had the range of -5 to 5, and it used the LFO depth percentage as the, I guess, I don't know where the constant or the percentage you wanted for the user not to change. Then we do bipolar modulation on that, and then you multiply that by the output of the triple LFO. And then this all gets added together, plus the delay time, or the normalized delay time, and this is processed through the inverse comb filter, and then through signal gen data we return the normal output. So that should give us the modulated delay time. Also here is the linear mapping for the inverse comb filter, and I got this. I'm not sure. I'm pretty sure I figured this out myself. You didn't supply this. This was just like the proportion or the range I got from the delay time knob. So whatever the min was over the max, and that was set equal to the min of the comb filter over the max, and then I solved for whatever the value was in the middle. So like if it was like, oh, if the knob was 2/3 of the way up there, I wanted it to be 2/3 of the way up in the range for the comb filter, and I return that, and that gets sent into the delay time of the scalping filter, which is universal comb filter parameters delay. Yep, there it is. And I set that back. So this is using oh, never mind. This is not using your template. I used your template though on the Echoplex tape delay, so I'll go through that. But you know, a lot of it looks pretty similar to your stuff. So for the Echoplex tape delay parameters, we have the two EQs, which is the low pass and high pass right here, and we set those frequency cutoffs to 8,020 hertz. We have the peak limiter, which we are adjusting the threshold and makeup gain on, and then I added a feedback gain knob, and it's linear. Well, I know your other two are in dB, but just for ease of use, I didn't really want the user to mess with it too much, so I just had a linear feedback knob to adjust that signal coming in and tuning it if I got it to work, which I did not. Then going into actually starting in the member variables all the way at the bottom. Yeah, so here are the three things I'm using, or the 1, 2, 3, 4, 5, 6. Yeah, the 6 things I'm using plus the system noise generator. Obviously two high pass filters and 2 low pass filters for each channel, and 2 peak limiters. And then in set parameters, you can see that I'm setting the knobs above to the frequency cutoffs of each filter, as well as I'm setting the thresholds from the knobs and the makeup gains. Now if I go above to I want to go to reset. Where is that? Okay, yeah, in reset, you know, this is what I thought would be the correct way, because we are using the audio delay. I looked a lot when trying to make this code. You said look back on the audio delay, so I tried to see how it was implementing a lot of the delay time, as well as the universal comb filter. I looked a lot, you know, or I looked back on. So first I knew I had to create a buffer of some size. I chose 800 because of my ranges for the delay time seemed to end at like 700 milliseconds, so I thought that would be plenty of length for a buffer. Here I'm just setting up the filters, so that's, you know, nothing special. And I'm setting the system noise generator, or resetting it, which is nothing the usual, but I think probably you want to hear me talk about the process audio sample and process audio frame functions. So this is for processing a mono signal, and right off the bat I'm using my record level, playback level, and dry level. And they're all in dB, and I'm flipping it to a raw signal, and then here is most of the delay stuff, and that's pretty close to the universal comb filter, where the output of the filters is set to DN, and then I'm creating the delay line from the mod delay, and I want to use that as the delay time in samples, because it said that I had to read a value in samples, so I multiplied the signal by the sample rate to give me an approximate amount of samples that you would need to be delayed by, and I read that signal into YN. So that signal YN's added with a signal noise generator, and then it's processed through the peak limiter, and then this is for the feedback. You take the limiter out and you multiply it by our feedback gain, or in my case it was just a linear knob, so just that one parameter I had created. So multiply those two together, and then add the initial delayed signal DN, which was the output of the filter, and then write that back in to the buffer. And yeah, that was what I thought would work. I had some issues this morning. I kind of ran out of time, but I know if I spent a little bit more time, I'd be able to finish this. And I do plan on creating the GUI and everything for this once I have time, post graduation. Woohoo! Yeah, and then the exact same thing is repeated for process audio frame, which is dealing with like stereo signals. I'm just repeating that twice practically throughout that, and I didn't get a chance to really look at the at how the yes I did, yeah, and I'm reading the signal between the either a normal or ping pong algorithm, and that's outputted and multiplied by the dry signal and wet signal are added together, and then that is my output. So yeah, that is what I had. Hopefully I can get some credit on that. I'm probably going to send you my .h files anyway for this, because I remember seeing a 0 on my comb filter, even though I remember submitting it. So just so you have everything in mind that you know for sure I did. So thank you, Will. Thanks for a good semester, and hopefully I will see you during graduation.